In grade 2, students should be able to use place value understanding and properties of operations to both add and subtract. We want our kids to fluently add and subtract within 100 using strategies that are based on place value, properties of operations, and or the relationship between addition and subtraction. We want them to add and subtract within 1,000. We're going to look at some concrete models for subtraction and the relationship between addition and subtraction. We want them to understand adding and subtracting in 3-digit numbers. They need to know that they add or subtract the hundreds and hundreds, tens and tens, and ones and ones, and sometimes it's necessary to compose or decompose tens or hundreds. Finally, we want them to be able to mentally add 10 or 100 to a given number between 100 and 900 and mentally subtract 10 or 100 from a given number in that same range. All right, so let's look at some of the strategies we're going to use to help kids do that. So the first strategy we want to look at is the concrete model. Okay, so just like with addition, we're going to pull out the base 10 blocks to help us illustrate what's happening when we subtract. So I want to subtract 243 minus 61. So I'm going to start by representing 243 with my base 10 blocks. That's 2 hundreds, 4 tens, and 3 ones. So I'm going to need 2 flats, 4 longs, and 3 units. All right, so this is 243. So let me write, I represent 243 with the blocks. All right, now I look at 61, and that means that I need to take away 6 tens and 1 long from 243. Now, if I look at my picture, I only have 4 tens. So I'm not going to be able to take 6 tens from those 4 tens. So what do? I take one of the flats and I decompose it into 10 longs. So remember, 100 is the same as 10 tens. Okay, so I'm going to decompose this flat into 10 longs so that I can then take away 61. All right, so let's turn the page to illustrate that. Now when we take away, see if we can get it to turn the page. My goodness. There we go. I'm going to cross out 6 longs, 6 tens, and 1 unit. And then I'm going to count what's left. So here I have 100, this is 1, 2, 3, 4, 5, 6, 7, 8 tens, or 80, and then 2 ones. So what am I left with? 182, right? 100, 8 tens, and 2 ones. All right, I want you to pause the video here and go ahead back to the site with the base 10 blocks and practice doing some subtraction on your own. I've got 4 problems here on the screen for you. Practice breaking down, decomposing our tens or our hundreds to perform the subtraction. In each of these cases, you should start by representing the top number with your base 10 blocks and then start decomposing if you need to. All right, so hopefully you've practiced a little with the base 10 blocks, and we're going to move on to another model for subtraction. This is the equal additions model. And the idea here is that if I'm subtracting 2 numbers, and let's try with a small example. If I want to do 8 minus 2, for example, if I add a fixed value to both 8 and 2, that's not going to change the value of my subtraction. And that's because if I say add 1 to each, so now I have 8 plus 1 minus the quantity 2 plus 1, that's going to be the same as 8 plus 1 minus 2 minus 1, right? That minus sign distributes. And you can see here I have a plus 1 and a minus 1. that cancel. So that just gives me 8 minus 2 back. All right, so that's the property that we're using here when we do the equal additions. The idea here is that I want to add something to the number that I'm subtracting to make it a little easier to perform the addition or the subtraction problem. So I want to add something that is going to turn that last digit and maybe the tens digit into a 0. Okay, so in this case, I'm going to add 7 to both the top and the bottom numbers. And I'm going to put parentheses here just to remind us that we're subtracting the 163 plus 7 here. All right, now when I add 7 to each, I'm going to get 262 minus 170. And again, I can add 30 to 170 to bring that to 200. So I'm going to add 30 to 262 and 170. And that's going to give me 292 minus 200. And now I can just do my subtraction without having to borrow, right? So 292 minus 200 is a little easier to subtract. That's just 92. And so that means that 255 minus 163 is also 92. The counting up algorithm, we want to think about making change. So if you've ever gone to the store and you pay, maybe your total is $13 and you pay them a $20 bill, they'll start, when they count your change back, they'll say 13, then 14, 15, 16, 17, 18, 19, 20 to give you your $7 back to get to 20. So let's look at an example here. So I have 100 minus 42. So I want to start with 42 and I'm going to count up to 100. So I'm going to do this in a couple of steps. The first thing I want to do is add 8 to 42 to get me to a nice number of 50. So 42 plus 8 is 50. And now to get from 50 to 100, I could just add 50. So 50 plus 50 is 100. And now I'm going to look at those numbers that I added, 8 and 50. And so that is my answer to, my subtraction problem. 100 minus 42 is 58. Because I showed that when I start with 42, if I add 58, I get up to 100. So again, in my change example, if you paid 20, they might give you a 5 back, right? So they might say 13. What happens when I add 5? 18, and then 19, 20, right? So they've given you 5 plus 1 is 7. All right, so that's the idea with your counting up algorithm. The traits first algorithm is really similar to the standard algorithm. It's just that we're going to do all of our regrouping before we do any subtraction. So again, this is often paired with the base 10 blocks. So let's try doing that with some base 10 blocks. I want to do 134 minus 47. All right, so the first thing we want to do is illustrate 134 with the blocks. So that's 100, 3 tens, and 4 ones. All right, so there's my 134. Now I want to subtract 47, which means I'm going to need to remove 4 tens and 7 ones. And looking at your screen, you can see I don't have either of those. So I'm going to need to decompose some things. So let's start, before we do any subtraction, we're going to decompose. So we're going to decompose this 10, and I'm going to change its color just so you can see what gets decomposed. And I'm going to break it down into ones here. All right, so let me move these over. All right, so now I definitely have 7 ones that I can take away. I still need to have 4 tens to remove. So I'm also going to need to break this 100 into 10 ones. So, or sorry, 10 tens. So here it is. Whoops, let's try to keep them separate. All of a sudden, it's not letting me do anything. Here we go. All right, hopefully you can see all of those. Let's move these so they're not touching. Okay. All right, now let's remind ourselves these ones came from the hundreds. Now I'm ready to subtract. This is giving me a hard time for trying to color these. So I'm not going to worry about it. All right, so I want to subtract. I want to take away 4 of the 10s and 7 of the 1s. So let's just actually delete 4. So I'm going to delete these 4 in the middle. Let's start with this one. 1, 2, 3, 4, and 7 1s. So 1, 2, 3, 4, 5, 6, 7. And what am I left with? I have 1, 2, 3, 4, 5, 6, 7, 8 10s and 7 1s. So my answer is 87. All right, now just to illustrate the standard algorithm here, what we would do is we took a 10 apart, right? So we reduced that down to 2 10s, and we added those 10s to the 1s to get 14 1s. So now I have 14 minus 7, that's 7. And again, I needed to take apart my 100, so now I have 0 hundreds, and I added those 10 hundreds to my those 10 10s to my 2 10s, so now I have 12 10s, and 12 minus, whoops, that should be 12 minus 47. So 12 minus 4 here, let's fix this, is 8. Okay.